Hello, I'm Raymond from Project GUHeat, and I'll just be presenting about the output maps of the project, the tools we used, hold on, the tools we used in creating these maps, and also a short demo on how to use these tools. So first, let's take a look at the output maps. This one is an air temperature map of Davao City Hall. This actually is a set of 3 maps showing different times on April 15, 2019. One at 9 a.m., this one right now, another at 1 p.m., and the last one at 5 p.m. Okay, so what can we do with these maps? One thing these maps can be used for is in urban planning. Let's say you want to conduct a greening project to mitigate the effects of urban heat. One factor you can take into account is which areas would benefit the most from it. With these maps, you can see that some areas have higher temperatures than others. Oops, like this part here. Um, Based on that, you can decide to do the greening project there, or that is where it'll be most effective. Of course, there are other factors to consider, but this is just an example. With this, you can also see the most at-risk areas throughout the day. Like in this one here, the highest temperature at 9 in the morning are here in this area, which I think is a roundabout, and also here, which is like a main road, I think. At 1 p.m., this part is still the hottest, but this road over here isn't as hot anymore. So maybe you can schedule your events in the area around that. We also have maps of the other side. These are maps of Claveria. It was split into 4 smaller sub areas in order to make the processing time much shorter. Usually, processing a large area like this takes days, and we don't have that much time. So, also we're not using a supercomputer, so we don't have that much time really. Okay, so another map by the project is this air temperature difference map. This one is it shows one of the sub areas in Claveria. This shows the difference in air temperature between 2 user-defined scenarios. Scenario 1 here is the current scenario, while in scenario 2, some of the open areas have been converted to buildings. We can see that after adding more buildings, the temperature in most parts of the area didn't really change much at 9 a.m. and 5 p.m. However, at 1 p.m., for some reason, most of the areas got cooler. There are also these small areas here and here that got hotter at 9 a.m. and 1 p.m., but didn't really change much after. Um, so we can then do analysis and figure out why that's happening. Like, why did the temperature change this way after adding buildings? Again, we have maps of the other areas as well as, but putting them in the PowerPoint would take up too much space. Okay, so here is the third map. It shows a land surface temperature time series of Davao City from March 2019 to from May 2019 to March 2020. With this, we can see the trend of temperature in the city, like how it got cooler in July and then much warmer in March. A more accurate trend can be determined by adding more images, preferably the images of months in between. Okay, so now we discuss the tools we used. So we have 3 main tools used in the project: Google Earth Engine, GUHeat Toolbox, and ENVIMET. The first one is Google Earth Engine. So Google Earth Engine, it's a cloud-based computing platform. It also has access to a huge database of satellite images. So pros and cons, like I said, it has access to a lot of satellite images. These satellite images are free, by the way. And so there is no need to download the images before processing. It is also cloud-based, so most of the processing is done on Google servers. This alleviates the computational load on the user's PC. And meaning the older PC, even older PCs will be able to produce good output, and processing times are usually much, much faster than if you're doing the processing on your own machine. However, also because it's cloud-based, an internet connection is required. Also, it is necessary to know how to code in Python or JavaScript in order to make full use of it. You can use Earth Engine apps created by other users, but you'll still need to know how to code if you need to make any changes. Also, there are cases where an API update breaks a code. In this case, you'll really need to know how to code to fix it. Okay, so this is just going to be a short demo on how to use the Project GUHeat Google Earth Engine app. First, you have to open your browser, and in the address bar, you enter this URL, then you press enter. So here we can see the GUHeat engine. It is an Earth Engine app created by the project. And what it does is it automates the land surface temperature computation using Landsat images. So to start, you first select what satellite you want to use. You can use Landsat 4, 5, 7, or 8. For this demo, we'll just use Landsat 8. And then you select whether you want to use day or night images. After that, you'll see that the app will load in this new layer. This layer just shows the Landsat tile footprints over the Philippines that are available. You can click any of these tiles to automatically set the path and row field here of the area that you just clicked. So since I clicked this tile containing Metro Manila, it set the path and row to 11650. After that, you can set the start and end date that you want to process. So for this demo, we'll just set the start date to January 1 and the end date to January 31. Then once that's done, you click Generate LST. So after a few seconds, the outputs should be loaded here. There we go. So as you can see, there are 2 dates available. You can also see the dates here in the list of layers. So we have one image that was taken January 4, 2019, and the other one was taken January 20. You can also turn these layers on or off if you want to check which image is better. Now to export, you can either use select on map the area that you want to export, or you can use view extents. So first, I'll show you what this does. So using view extents just sets the export area to the whole view extent, basically. But for now, we'll use select on map since we only need a small area. So once you click the button, you can draw a rectangle over the area that you want to export. Then you'll see that stored here as this layer called export extents. You can turn off some of the layers to make it faster. And then once you're done with that, you can click generate links. After a few seconds, it should show here we go, a list of download links here. So this image that we're showing right now is the one from January 4. So let's download that. So after downloading, you'll have this TIFF file. You can open this in any GIS software really. So let's open this in QGIS, and there you have it, an LST image. This is the one from earlier, the area that you selected earlier. That's it. So next is the GUHeat Toolbox. The Toolbox is a plugin for QGIS created by the project as an alternative to Google Earth Engine. So it's mainly used for computing LST as well. However, it has other tools included in it which your project uses for processing other stuff. So pros, it is relatively more stable than Google Earth Engine, as updates usually don't change much, especially if you're using a long-term release version. It also does not require internet access, so you can just download the images when you have internet and then just process them after. However, since you're doing the processing on your machine, the processing time would depend mainly on your machine specs. And most probably your machine isn't going to be as powerful as Google servers, so processing could take much longer. For comparison, processing a single Landsat tile in Google Earth Engine usually takes a few seconds only, while processing the same tile on my laptop can take a few minutes. The difference isn't that big, but if you're processing a lot of images, those small differences tend to pile up. Also, same with Google Earth Engine, you need to know how to code to make plugins and also to do maintenance in case something goes wrong. So now we'll be looking at the Project GUHeat toolbox. Dear. Oh dear. So after installing the toolbox, you can see it here in the menu bar of QGIS. So here are the available tools. For this demo, we'll just be using the land surface temperature. So we're going to be processing a Landsat 8-day image. There's only going to be one image, so we'll just set this to individual data. Like with the Earth engine, the GUHeat engine, you can also process Landsat 4, 5, 7 images. So first, you set the input path. This path is just going to be this folder. This folder contains the Landsat bands after extracting. So we set the input path to that. And then for the output path, you just set the path the folder where you want to save the output. And for the output file name, you just put the output file name. You can also turn on show results to automatically load the output into QGIS. So let's turn that on and then you press run. So after a few minutes, you'll see the output image loaded into QGIS. You can now close this window. So in order to properly visualize the land surface temperature, you can double click the layer here and go to the symbology menu, and then you change the render type to single band pseudocolor. And then here in the band, you can select band 6, which is land surface temperature. So there are other bands that you can display, but for now, we'll just show land surface temperature. You can also change the color ramp if you want. And you can also change the mode here to make it easier to visualize. So we'll use quantile and you can increase or decrease the number of classes. Then you just click apply and OK. So there you have it. This is the processed LST image. The yellowish parts correspond to higher temperatures, while the purple and pink-ish parts correspond to lower temperatures. That's it. Okay, so the third tool is ENVIMET. ENVIMET is different from the other two in that it is a simulation software. So with ENVIMET, you provide it with a model of the area. Usually this model includes buildings, vegetation, land cover. This image here on the left is an example input model for ENVIMET. The gray blocks represent the buildings in the area. The green spheres represent the vegetation canopy, and the surface color represents the surface material. In this case, the brown orange areas represent soil, while the light yellow areas are sand. You also provide it with atmospheric parameters such as air temperature, humidity, wind speed, wind direction. And the software then takes all this data and it simulates the microclimate condition in the area. This simulation can then be used to analyze the effects of the structures and other objects in the area on the environmental factors such as temperature, humidity, wind speed. So one of the outputs of this simulation is this map, which was actually shown earlier. So in this map, you can see the air temperature and the wind direction. So these are just two of the many available simulation outputs when you use ENVIMET. And now, short announcements. The GUHeat toolbox and the GUHeat engine that I showed earlier, it'll be provided during the closing webinar on August 14th. The soft copies of the maps will also be provided then. And if you have any other questions, concerns, you can send us an email to projectguhit@gmail.com.